So welcome back from the poster sessions. I hope people had as much fun as I did getting around to those. Kudos to Selena for the new platform Four Ways, at least from my perspective. That worked very smoothly to find things and click around and move. So thank you for that. And we're going to move quickly right into our next session, session two. So hopefully someone is sharing the link to the shared docs. We move to a new Google Doc. It'll be bit.ly slash MaRDA2026 underscore two, but I'll put it there if Selena's not back yet to put it there. I'll put it there in a second. And so this panel is about, it's the materials, first of the materials industry panels on the emergence of data-driven AI. So this next session is really meant to highlight this AI-enabled frontier of materials research included in R&D portions of large organizations like IBM and Microsoft Discovery, who are both graciously here, to startups and these new firms we've been seeing like Periodic Labs and Lila Science, who are also here. So I think as we think about connecting stakeholders across this data AI continuum, we're really interested to explore how AI is affecting things as diverse as workflows, data practices, validation, and just what it really means for the community, the stakeholder ecosystem, like in MaRDA, for putting those things together, where collaboration is meaningful, where does trust maybe break down, what infrastructure do we need to accelerate this real world impact. And so I'm going to turn this over to Ben Blaiszik and Jake Yeston and Cate Brinson, who are moderating this panel. And I think specifically that means Jake, if I have my notes correct. So I'll go quiet. Thanks.
Okay. All right. Yeah. Thank you so much. Thank you, everybody. And unfortunately, Microsoft, we were a little bit late sending that invitation, and so she's not going to be joining us today. But we still have three really excellent panelists, and I think we decided we're just going to kick things off by asking them to introduce themselves briefly and give a short introduction to what they're doing. And so we'll start with Tim Erdmann at IBM.
Yes, hello everyone, and very big thank you from my side and from IBM side for the invitation. We are very happy and very thankful for being here to speak to all of you and with you. I'm a staff research scientist at IBM. I joined IBM about 8 years ago. My background is synthetic polymer chemistry, so I joined IBM as researcher in the lab, creating polymers, analyzing them, and then transitioned by a self-guided learning path into software engineering to be more productive in the lab myself, and been generating a lot of data that makes a lot of sense. And I followed this learning path over like the last 8 years, and now transitioned completely into a software developer for applications in the field of material science and chemistry, and especially I've been developing ChemChat, which is a LLM-driven conversational assistant, as you see from ChatGPT, but specifically for chemistry. I'm building a lot of tools using MCP servers, ACP, and so on.
All right. Let's see. Is everybody on? Santiago, is your camera on?
It is now.
Okay. All right. Fantastic. You want to go next?
Sure. Hi, I'm Santiago. I'm the Director of Materials Intelligence at Lila Sciences, and what I do is I try to build materials intelligently. There's two things I think that are worth noting about Lila in the introduction. The first one is that for each program that we do, there is a physical world instantiation of it. So there is actual equipment making actual things and measuring actual things. And then the second one is this idea of breadth being depth. So we have discovery programs both in the life science and in the physical sciences. And within those two domains, there is a diversity of different things that we work on. So that means multiple material systems for multiple applications.
All right.
And I think I saw Abhijeet there.
Yeah, is he?
but
I'm
I-
just looking
Yes,
to
can you hear
see if
me?
people's Yes,
Yes.
yes. Okay, great. We can hear you. I'm not sure your camera's
Yeah, I think I told Kate that I would have the camera off because yeah.
All right.
If that's okay?
Yeah, absolutely. We
Yeah.
can hear you well.
Yeah, so yeah, just to introduce myself, I'm just finishing up my PhD from UCLA, and I was an intern at Periodic Labs, but I'll be joining it full time soon. So my background is mostly in physics. I also do computational material science in general, and my projects usually relate to developing software for accelerating, atomistic simulations. I also maintain two of the atomic simulation package, Torch Sim and JaxMD. So that's basically my background, and yeah, so.
All right, terrific. Ben, do you want to kick off with the first question?
Sure. So just to let everybody know, I will be monitoring for questions in the document, so please put them there. Also, I think we did invite the panelists to have slides if they'd like to show them. I don't know if they have any, but if you'd like to, please feel free. Otherwise, we'll move into the questions. Does anybody have anything else they'd like to show to get us kicked off, or are you all good to go? Okay.
No, we're good to go from my side.
Great. We'll move to questions then. So we'll start with Abhijeet since you were just on. I know you've had an interesting career path, with internships in both industry and national labs. Wonder if you could tell us a little bit more about that. Like, what does it look like? Think about like targeting this towards students.
Yeah, I think the main difference is, when you work in industry versus working in academia, many of the research problems or like the target problem for is like very targeted. So it's like it's a very focused kind of a goal. And I guess the other main thing which I felt like was a very big difference from academia versus industry is that, you're not resource constrained, right? You have access to a lot of resources and you can do things at scale, which is usually very restricted to do in, academia. And that opens a lot of different avenues in terms of like doing projects which are at scale. The other thing I guess is like, as I mentioned earlier, is that in industry you have like a particular goal per se, where all the team is working towards that. PhD programs can be more fragmented, like maybe a individual student does his own program versus maybe two or three collaborators work on it. But it's like very small size of team working versus like, especially in a startup, right? Everybody is like focused in solving this problem. So I guess that's a big difference. But I think the one I've felt personally is just the amount of resources you get, especially if you're a computational person, right? If you want access to GPUs or something, those are more easy to get in like an industry setting.
Thanks. I'm gonna jump to the first question in the Google Doc, and it's actually a question I had too, which is how often does the industry benefit from open source publications? I'm not sure if by open source this question specifically means open source software or if they just more generally mean the open literature. And the data that academia pushes out, and what are some ways where industry and academia can help each other. And Tim, I'd like to start with you because I know that IBM does sometimes publish in the open literature. In fact, we've seen IBM papers in Science, and so I'm curious how in your position you navigate, what's going to go to the literature, what's going to stay in the company, and likewise the nexus of what you bring in from the open literature outside.
Yeah. It's a fantastic question because I'm in a position where I would like to publish more than I'm allowed to based on working on a product in the Gen AI and agentic field. So it is definitely like what we are allowed to. Like IBM is a big supporter of open source and publications and to drive the research community as a whole. And also we are getting a lot of back as well from that. And so it is always bound to like what kind of projects you're working on. If it's more research focused or if it's like more product focused. And this has changed over the years from IBM from a more like free research and also covering more fields in the material space to like a way more narrowed down over the last years. So that's the main constraint that you have in the industry, that you cannot just publish everything that you work on.
Santiago, you want to comment on that from a sort of younger company?
Well, the I mean, Abhijeet mentioned that an industry and not resource constrained as it comes to hardware, but you are definitely resource constrained as it comes to time. So in a younger company, there is a lot of emphasis on spending time on things that are just kind of like important and ideally help with whatever it is that the company decides to do. And sometimes that will lead to a publication, sometimes that will not. It's just hard to predict that before you start. In larger companies, many times a project or an effort is scoped to either be open or be closed. Like you have this like product versus research distinction. When you're still trying to create everything from the ground up, it's unclear what's going to be product and what's going to be research. And essentially, we just have to go through the process and see where we end up.
And do you feel like at this early stage you benefit from looking at what's in the open literature, or is it more, for IP purposes, we have to kind of reinvent the wheel?
There's a range. The interacting with the open ecosystem, I think, is very important for a variety of reasons. Um, there's just knowledge exchange, just plain and simple. Even though, some institutions might be best in the world at something, they're not, best in the world forever at something. So being able to engage with others on the diversity of things that make up like AI and material science, which is, a union of two fields, is quite important. Then practical things in terms of data, algorithms, and things of that sort, that's also gonna depend on how well it matches with what the goals are. There's some overlap, I would say, in some cases more than others, but there is always going to be this fundamental disconnect of what the publishable world, so to speak, cares about. It cares a lot about novelty. It cares a lot about convincing reviewers in the community that there is a fundamentally new capability being developed. And on the corporate side, it's a lot more about proving utility, right? There is going to be things that are open that are very useful, and those tend to be adopted more easily. But things that are just novel don't necessarily get adopted just for their novelty.
All right, Ben, you wanna?
Sure, yeah. So Santiago, while we're talking with you, uh, what does the world look like with scientific superintelligence? Right? This is one of the claims that Lila's pushing towards. What does the world look like? And we also talked during the first session about building shared infrastructure, right? So what are the types of shared infrastructure that we need as a community to help reach these levels?
Well, what does the world look like with scientific superintelligence? Ideally, a lot of things get a lot easier. There's many questions that we've been asking in materials design that have kind of like stuck around for a long time. So things like PGM-free catalysis, right? For example, is one that we've been working on a long time. Different discoveries of a whole bunch of like other materials, superconductors being famous. Maybe those become easier to discover and easier to evaluate. On the life science side, there's also like multiple examples. I think like one early example of scientific superintelligence with machine learning is really AlphaFold in the sense that it accelerated the process of what it is that you could do in the life science field. Related to shared infrastructure, in many ways, the way that a lot of this starts is really by conversations that allow us to go beyond some of these like superficial intersections to try to understand what each other's goals and what each other's needs are and how it is that we can best intersect. There is like some things I think that we're doing already. There's many proposals in terms of being able to host data, being able to kind of like catalog different things. There might be ways of like sharing compute. There might also be ways of sharing other types of resources. So if we're thinking of experimental capabilities, particularly automated labs, if those can receive requests and how can those requests be received and what are the reasons for sharing like automated lab capabilities, whether they live in institutions like Lila or at Argonne or somewhere else, how is it that we can kind of broaden their availability, if you will? That is like a question that is both technological, but also, I think, I don't know what else to call it. Like some might call it business development, some might call it, um, yeah, some human organizational component is there that I don't quite have the word for.
Yeah, and I guess I'll ask the other two panelists to answer a slightly different question, which is, what does the world look like if you're successful? I won't ask you to frame it in scientific superintelligence per se, but like, what does the world look like if you're successful? And also, what are the things that you need from the community for shared infrastructure, whether that's shared from your side or shared from the academic side?
I guess I can go with the shared infrastructure part of the question, if that's okay. Yeah, I think with regards to like scientific tooling, it's kind of important to have like a, like community comes together and builds like the softwares. Like we all use, stuff like PyMedGen or anything that's related to material informatics. All the popular known packages, they are all open sourced, including a lot of the simulation tools like AAC, LAMPS or something. So having that kind of ecosystem is kind of very important. And once you have this software, then you can that enables people to do a lot of good science. And also if you're in a startup, many of the startups, instead of building everything from scratch unless it's needed, would use these tools. So having this community support for the scientific software ecosystem and also building around it is kind of I think it's a very important thing. And that's why companies or like startups should very much contribute to open source software, because we all benefit from it, rather than having like closed source kind of a nature. So yeah, I think open source software is definitely one of the key things that would help everybody build like a good shared infrastructure across that. And then there is the question of compute, right? How do you get the compute? But yeah.
Yeah, and let me dig in a little bit on that, Abhijeet. So I know recently you had a partnership with NVIDIA uh, and TorchSim. So I'd like to hear your thoughts on why that works so well or how it works.
Yeah, so I think that was a very nice experience, basically collaborating with NVIDIA, because we had this, we have taught them basically, and they were able to accelerate it with their, writing their own kernels and helping us uh, integrate with their, kernels. And the nice thing about this was that it was pretty quick to get this going from both the sides. And just like this, with the collaboration we have, we get like a really good speed up of 2 to 3 times for like a day-to-day simulations, right? So, and everybody benefits from that. Their package is open source, torsim is open source, so everybody has this productivity multiplier basically for their simulation or whatever workflows it is. So like going to the previous point, hence it like becomes like very important, different either be like communities or different people from industry come and like try to integrate together tools and make things faster or like better in general.
Yeah, and
Great.
regarding like shared infrastructure, I think there's a ton of high quality data out there, but it's just very siloed. So I actually built like a federal um, data platform where we have, or where you can agree on standards of how to report data regarding the instrumentation as well, that more people can use high quality data. I think it only missing is the incentives for actually creating such a platform, because it takes actually a lot of time and to build it, and universities are actually not or university groups are not awarded for that. They're awarded for publications, and this is actually something that goes far outside of where their time is spent most effectively.
Right. I had actually a quick follow-up question that I was thinking of on data in particular, and I'd be interested in comments from everybody about how are you obtaining the data that's needed to push forward these missions? And I think it might be quite different at a legacy company like IBM, where you may have a lot of internal data. And a company like Lila, where I think you're creating rapidly a lot of data with automated labs. But how are you dealing with the data problem just in general in order to push forward your mission? I'd like to hear some comments about that from the different perspectives. Thank you. Maybe start with Tim, since you were already speaking.
Yeah. When you think back about IBM and all the advances in the material space of IBM and the years that when it started, when it was the high field of IBM's research, everything was more written down in lab journals than electronically. So when we are harvesting data, going through data for new projects and thinking about using data from the past, it's definitely just a lot of manual work. And it's, even though with the advances of image recognition and LLMs, it still takes a manual process, because how people write structures, it's just in their own style, like how they abbreviate things and so on.
Right. So even though you have a lot of data, it's still it's still another effort in order to capture it and use it.
Yeah. This has changed over the years, of course, but more the bulk of the data is still in lab notebooks.
There's a couple of questions with a common theme that I think maybe all three speakers could have an interesting perspective on, which is this idea of, moving from sort of candidate material or candidate idea to something that's really actionable and marketable. And, I think we heard earlier from the speaker from the Air Force lab that, there was this titanium aluminum alloy that's now widely used that took 50 years to develop. And so I think the theme of these questions together is, is AI helping with that, from the lead to the marketable product, or is it really mainly at this point only helping with generating the lead?
Well, you have to start somewhere. Otherwise, you're never going to get anywhere. So what is the generation of the lead, and where do you draw that boundary? Is that a computational CIF file description? Is that an actual sample realized on research equipment? Is that a thin film? Is that a powder?
I would say
the equivalents are somewhere else. So that's kind of like what I'm saying. Like, you can progress step by step.
Yeah,
and each step kind of like takes you closer. Sorry.
I would say, if I had to put a sort of quick descriptor on it, I would say, it's something that's going to make your company money, right? That, I think that's from the corporate perspective, that would be the end goal, right? You're sort of at the point where, you've moved past the discovery phase to, like if it was a pharmaceutical company, where we have a drug now, that I think that's that's kind of the question was sort of the last mile part.
Well, even if we look at the pharmaceutical space, since you mentioned, what many drug companies do is they partner with like a Pfizer to do manufacturing. So even there is a handoff. So if you're talking about the large scale manufacturing piece that then gets into consumer hands, there's many steps beforehand, and a lot of like economic value gets created at the different steps. And many times, at least in the past, and maybe this will be changing now that we have like new tools available, the system has just kind of evolved to land here, right? Where like one company does something at some scale, then they sell that to like somebody else that then scales that up, and so on and so forth. You see this not just in drugs, but you see this in the semiconductor industry as well. There is a huge like network of suppliers that then come together, that then build the fab, and then there's material suppliers that kind of like interact with different processes of the fab, and the fab integrates it all together. I think that is going to change how these different like interfaces get negotiated with many of these like discovery programs coming online. So what I'm hoping to see is that what it is that we can discover is gonna be more valuable, in that sense that you're gonna you're not going to be bound by the way that the handoffs have happened in the past, if that makes sense.
Yeah, absolutely. Tim, your thoughts on this last mile problem?
It always depends on also how much data you have for which step of the process. Um, I think AI can definitely accelerate all the areas. Lead generation is probably the one that we have a higher multiple than on the end phase, but maybe due to the lack of data in a specific area, because the further you get down to the final product, that's a thin film or something like that, you're very specific. Highly likely have to create your own data for a specific new material to make the right conclusions. So this can be a little bit slower based on the availability of data for the specific product you're working on. But when you can use like similar models and can transfer the problem, so there might be still already solutions out there, just not for your material, where you just unfortunately need to create the data yourself.
Yeah, no, thanks. Abhijeet, any other thoughts?
Yeah, I think going like end to end with like having some prediction to like a end manufactured product is like a big challenge. But I think like, at each stack of this, like AI is going to accelerate in some way or another, be it your computational stack, be it your experimentation or instrumentation. So I think at some point there is going to be like this logistic problem of going from like, oh, new discovered material to like making it into hands of people is going to be much smoother. But yeah, I don't see like a instant solution to it, but it's going to be there with like different things that would be streamlined with AI.
All right. There's another. This gets a little bit into Cate's question earlier, just about metadata format markup, things like that. Is there something that people in academia should be doing? Well, certainly there's always something they should be doing better, but is there sort of a framework that they should be following that would help industry make better use of their data? Or are we nearing a point where, the LLM will just figure it out when it crawls literature on its own?
Well, it's an unsolved problem, so any ideas are good ideas, is the short answer to it. And is metadata going to be important to be able to do the kind of things that we want to do? I think yes. And hopefully the boundary of what it is that we consider to be metadata is going to change over time with that as well. Because like metadata just kind of implies things that we take in addition to the important thing. Well, maybe some of these are going to be migrated to the important thing and thereby open up like a new space of what we consider to be metadata.
Tim, anything to add?
Yeah, like regarding reproducibility, having metadata, having more documentation, more data, in form of like not only the important values but the all the surroundings is, I think, very important for an anomaly detection if something doesn't work as expected.
I mean, I wonder if there is, I'm not familiar with it. Obviously, there's all sorts of, sort of data like Research Data Alliance and Force 11 and so forth. I don't know if there has been an industry standard that someone has put out that said, this is the metadata framework that would be useful for industry. And, I mean, I wonder if that's worth considering, someone just having a sort of call to arms, so to speak, that says, this is how we'd like you to help us do it.
Well, I'm not sure how we can break the XTCD comics curse of there is 500 standards who don't meet our needs, so here is a 501st.
Right. Yeah, no, I hear that.
So so I would expect there to be many more standards that continue that trend, and hopefully as we move into more, the ones that are new become more useful, and then eventually will converge. We'll have like a couple of different things that end up converging. So instead of having 500, maybe we'll have 10. That would be a lot of progress. Like the problem is like right now we just have an innumerable amount, and hopefully that will reduce to like a more practical one.
All right, Ben, I'll pass it back over to you.
Yeah, I think this question from Jim Warren kind of is in the same ballpark, which is how important do we imagine the literature is going to be moving forward? This is not to say publications are not important, et cetera. It's like for the data aspects, right? Like when you have a robotic lab that can generate exceptional amounts of data, is it worth reverse mining the data from literature? Um, I wonder if people can comment a little bit on where there would be value to mine uh, from the literature and where the robotic labs might take it next.
It could also tie into maybe something Tim said earlier about how even though IBM has a ton of legacy data, that it's not in the right format and it's a big lift to pull it back out. So it sort of couples nicely with this question of, is it worth it? Is it worth it to do that? Or do you really just generate new data quickly in some automated fashion instead of going back through the effort of trying to mine this legacy data? So Tim, do you have any thoughts about that? Have you run into that with data at IBM?
What specifically?
So I think it's the concept. So the original question was about, do we need to go figure out how to mine all the previous literature for data, or do we not need to do that anymore? Can we stop and just use rapidly built automated labs that can grab a lot of new data with fresh tools consistently, quickly? Does that negate substantially the need to mine old data in order to use it in the future knowledge prediction? And so in a company like IBM that has a ton of this legacy data, in addition to, of course, literature that's out there, so sort of the same problem, right? Do you really need it, or would it be faster to just build a few little lab setups to go get what you need now in really rapid pace?
That always depends on like what the problem is and how fast you can generate the data. And so it depends on the chemistry, for example, when you look at it, or on the preparation of let's say if it's a film or if it's kind of formulation. And if you have the tooling for that, because there are some simple, you can use syringe pumps and set like a flow reactor up, which is very simple, low cost. But when you go more to like advanced machines like ChemSpeed, it's very costly. It takes a lot of time and training. And so to me, I would use the parallel approach. I would just, if I can build the setup, I will set up and I have everything under my control. I know exactly parameters are staying the same. I don't need to worry that some of the metadata I get from papers is something incorrect, or how the data was analyzed is not as I would analyze it. So I can avoid all of these unknowns, so to say. And so, but in parallel, I would still like mine data with the help of AI and LLMs as best as possible. And then when I build my model, I would just like start with my data only, swap out some data points with the points I got from literature and see how the model then behaves. And so if that stays in alignment with when I use my data only, I think there's an indication that I can use this form of data from the literature.
Let's bring Abhijeet back into the conversation. I'm curious about, since you sort of still have a foot in both worlds, have your own data practices changed in the context of, what you do on the academic side after your experience in industry?
I guess on the computational side, it's a kind of the same problem, is that everybody runs their simulations with different settings. So it's difficult to have like a standard way of getting something. But I guess if you want to do something high throughput predictions with simulations, you need to have like some rough standards, right? So Material Project has this wonderful thing where they have a workflow and all the settings which they have benchmarked, which you can use for the thing. I guess that would be the standard if you're looking for standards in like density functional theory. So something using something like that instead of me just like looking at this system specific problem in academia and just choosing some settings regarding that, right? Sometimes it's applicable, sometimes it's not. But when when your target problem is broad, you're targeting different types of materials, it's good to have something which is well tested, right? And material project covers all of this different diversity of crystal structures and like chemistries and other things. So I think that becomes like kind of important to like stick to that and make sure what works, instead of like benchmarking us internally and seeing what which is like the best setting or whatever. And regarding the previous question regarding like if we can generate data in-house versus like taking whatever is available in literature, I guess that's a question of quantity versus quality as well there, right? So you would have a lot of data in literature, but you don't have control over what were the settings and how it was generated, what were the lab settings, etc. But in-house, the you won't have so much quantity of data, but you can iterate on it like pretty nicely, and the control parameters, how it was generated, and other things. So it's easy to iterate on that. So I guess that becomes like once you have the enough throughput, it's just better to like in-house generate like the data, right? Because it's fast to iterate on top of it, and where are the edge cases or whatever.
Santiago, any thoughts on that?
I think a lot of the ground has been covered. It's gonna be hard to know where it's going until we try it. And in some sense, we've only tried it on limited cases. So we have found out that if we put a lot of effort kind of like into some of this mining and extraction, there is interesting things that we can say. But how can we do that beyond these like specialized cases that take a long time? That's an open question. And depending on how that plays out against internal data generation capabilities, that's where we'll see kind of like which one ends up being more popular.
Looks like there's a question here about national lab collaborations. Are any of your respective companies, working on that, working with sort of public user facilities in productive ways?
I mean, I used during my PhD and I did intern at Lawrence Livermore, but not as a industry national lab collaboration. Yeah, I would be curious if anybody has thoughts on that, like if they had the industry and national lab collaboration.
Don't have any experience personally, but I think colleagues of mine were in larger like funded projects where national lab participants were also included. But I myself don't have any kind of projects that match that.
Yeah, I mean, because I wonder, when you talk about when the sort of autonomous laboratory becomes, more commonplace, less of a research prototype, and more, like the way you would talk about buying like a mass spectrometer, for instance. You buy like a synthesis machine, right? Is that something that is going to have a centralized facility? And if it did have a centralized facility, would industry, would they help fund that centralized facility? Would they sort of prefer that they have their own facility because they're going to want to do their own proprietary work? How do you see, sort of the role of industry in that kind of, autonomous synthesis future that we're all sort of talking about now?
Okay, I'll try.
Hmm.
There's gonna be things that are gonna be like market driven in the sense that you get clear demand. Anything that is clear demand from a market, that means industry solutions are gonna be built towards that. What those are, right? It's kind of hard to predict because it depends a lot on human decisions as well as like technology maturity. So that combination is always difficult to make reliable predictions on. Where I think many of these user facilities, especially the broader ones, can be useful is either if they are longer term looking, or if they are kind of like things that are hard for a single entity to maintain. So something like synchrotrons have been very successful because it's very hard to build a synchrotron and enough people need it for them to be booked out all the time, but not enough for everybody to build their own synchrotron. If there are similar things that just kind of like feel a bit more like synchrotrons and something less like, I don't know, an ALD depositor machine, that's where I would expect like user facilities to still kind of like be there. I think with like TMs, we're starting to see a variation where there is a lot of TMs and a bunch of like microscopy labs that are kind of like government user facilities, but also a lot of TNMs in industry, and they span different capabilities and different ranges.
So from IBM's side, since the focus of IBM is more, like not more, it's really like AI consulting, hybrid cloud company, and research has streamlined into this field as well. IBM, I think, would be a great partner to build the infrastructure on the IT side, especially with our What's Next platform regarding data curation, data management, data storage, the governance over the data. So if something changes, it's easily these kind of data objects can be removed from the training set. And we are talking about like huge amount of data here. If you want to train and fine tune your own LLM, for example, towards a specific field. And with new regulations, you cannot use a certain type of data anymore. So this can be like automatically filtered out and retrained. And it also provides the inference, not only with LLMs, for example, but also other larger AI models. So I think in this field, IBM would be a great partner for the IT side of the problem, so to say, of the goal. Regarding funding the labs itself, like automated infrastructure, this would not be something that IBM is highly likely interested in, based on the focus of the business.
So,
I guess
from my chemistry background, one of the things that people talk about a lot is that there's a much tighter focus on safety in industry than there is in academic labs. There's just they have a better infrastructure. They have sort of stricter rules about the kinds of experiments that you shouldn't do, the way that you should do experiments to be safe. And so I'm curious, in an industry standpoint, how you all have been navigating this idea that an AI system could either inadvertently or perhaps purposely create a product that is dangerous somehow, either to the users in the immediate vicinity, or to sort of the public at large, if this ultimately gets released somehow, whether it's an explosive or a dangerous chemical or what have you.
Guess I'll go first again. It's going to be a multi-layered solution. So just like any automated lab has multiple layers of complexity, that's going to require multiple layers of algorithms to make it productive. There should be also multiple layers of safety solutions for those things. We can start with like a base layer of, don't perform unsafe actions that will damage whatever the system is, or that will damage the immediate surroundings. And then there is like layers on top of that you can do for different kind of like algorithmic components. The LLM community has been active in how it is that you can diminish like unsafe outputs. They have a couple of different ideas, like obviously they're incomplete, but that approach is going to be different from something that interacts with the equipment directly. So I would envision these solutions like coming together in that staggered way.
Abhijeet, any thoughts?
Yeah, I'm not sure exactly how it would play out in the lab because, LLMs interacting with like instrumentation and setup and then autonomously driving it, that's still like not a tested boundary of how they would perform. One of the things is like, do they have any special knowledge of like where they are interacting or whatnot? So I don't know the answer for that, but like that could be a thing, right? Like if I'm moving my robotic arm in front or which position I'm moving it to. Of course, it's like really good with like coding tasks, but when you put it in, let's say, handling a robot or like handling some synthesis, yeah, I mean, I'm not sure how it would perform, and there must be some guardrails to put before you let it just do something. Maybe you put it in a simulated environment first and see how it does. Kind of like how Teslas were trained. So yeah.
Yeah, and when I think about the product I'm working on, like ChemChat, there are a lot of like guardrails that need to be in place first, like, and then also another like, as Santiago said, multi-layer approach is also like user group selection. Like we cannot release certain applications to like the general public because chemistry is inherently dangerous. So we cannot like necessarily give this tool to the hands of everyone, but then to research groups and other collaborators. This is another kind of like guardrail need to be put in place as a multi-layer solution to prevent misuse or potentially dangerous use.
I'll pass it to Ben and Cate.
Yeah, I've got a quick question. So if you had a magic wand that only works for work, uh, what would you currently wish for? Is it like better benchmarks, better algorithms, data sets, better robotics, compute, more capital, of course, uh, more trained researchers? Like what are the first couple things on your list that would help move you along?
Maybe I can answer. Yeah. So, I mean, personally, for me, it would be compute, but like being realistic, I think it's like, getting all the instrumentations and like the throughput for the instrumentation is like, I think, a critical bottleneck in a lot of automation processes. Some of the characterization takes like, you either require too many instruments to run in parallel, it's just like slow, and that can be a bottleneck in doing like high throughput, synthesis and other things. So I think that would like, unlock a lot of things. But personally, I would just like a lot of H100s, but yeah.
So and to us and our group would be definitely like time, which means more manpower, or researchers or interns. That would definitely help us because usually you have more ideas than you can work on.
I will go with capital. It's partially a cheap answer, but partially not. I mean, the reason for that is that there's more, like if when I say capital, I mean specifically like lab equipment. I don't necessarily like mean compute. There's a lot of like different avenues that you need to explore and figure out when you think about automation in terms of how it is that you rebuild or build many of the systems that have been deployed in the materials industry so far. And that essentially means that you need kind of like capital to iterate through your ideas and to create like essentially what are fundamentally new pieces of equipment.
Okay, that's fair. Money is always good, right? There's several questions that have been in both in the chat and in the Google Doc about IP and concerns about like how do you lift all ships but still retain secret sauce in-house so that you can survive as a company. And so I think it might be different perspectives from the different speakers here. So could you comment on this? And it could be about data for IP. It could be about models. It could be a variety of things. How do you think about IP and the sort of duality of retaining IP, but also giving enough out so that the next big thing can be found sooner everywhere. And let's see, I'll pick Santiago because he likes to go first.
Really? Okay. Well, it's gonna be, I think, in the near future on a case-by-case basis, in the sense that in order to release something, it needs to be valuable enough to release, but not so valuable that you don't want to release it. And it's kind of like difficult to hit that region, and especially to do it in a way that's planned. There are gonna be some examples where I think we'll do that, but we need to kind of create it first to understand whether this is like something that we think is worth releasing in a sense that it will lift all boats, or whether it's something that we want to keep, or what proportion for it that is. And the way that we would think about it is because we would want to kind of like encourage the community probably to go in a particular direction, right? So what I would expect is that we would want to make a statement about, we believe that this is important, and here is like something that we think will be helpful for the community to go in that direction.
Nice, thread the needle. Comment, Tim?
Yeah, it's like I can only echo that 3-day case-by-case basis. And sometimes research projects wrap up and then it's good to just disclose it and it's not necessarily worth fighting for IP. In other cases, it's like from the get-go already defined that we cannot open source this and we want to develop some IP because it might be a product that we're working on. So navigating this field is always, when research becomes more streamlined to the business, then it becomes more difficult to just to manage what you disclose publicly and what you want to secure IP for. Often in the past, we have done both. First, we filed the IP, and then we prepared the paper. To also, like, of course, drive the research community in the areas that we find interesting, that we find useful, where we see a lot of potential for advances of material science. But before we want to, of course, protect our own findings.
Right, thank you. Abhijeet, any comments about IP from your perspective?
Yeah, I think it's case by case, depending on the applicability, usefulness of the community, or like something somebody else is going to build. If you already have something, and then might as well release it. I think when it comes to software, it's always, I'm very pro open source to that, because also, like, you don't want to manage two different versions of the same thing, right? It reduces maintenance burdens and other kind of things. So, and we, like, most of the software ecosystem is like that's being used in many of the companies right now is like open source, right? So giving back to the community as well, or buy-in from the community for your specific software tooling. So I think that's pretty important. So yeah, I mean, the Torsim is one of the examples, right? So in my intern, me and Oran and the other team at Radical, we built it. And initially it was like a product by Radical, then it went to open source. And now there is a whole consortium, like Ben is a member of that. Maybe he can speak more on that. But overall, I think it had benefited the community a lot to come together and support this, right?
Right, that's a great example. Thank you.
So this is a more controversial question now than it would have been maybe 5 or 10 years ago. But I think a lot of this conversation tends to be a little US centric. And obviously IBM has a famous lab in Zurich. And I think that when you think about AI, you sort of think about international competition to a greater degree maybe than international cooperation. And so I'm just curious if you all think, what is the corporate role and the corporate challenges in sort of sorting through the kind of international political aspect of how we're ultimately going to govern AI going forward. Tim, you get to go first because I called out your Swiss.
No, of course. I was thinking about that. So, I mean, IBM being an international company with a lot of research labs, really are spanning the whole world from California to East Coast, to like we have some small areas in Israel as well, and Zurich to Japan, and so internally we collaborate on all of that. We don't have a specific location for a specific field of research, but all of this is interconnected. So within IBM, we are internationally collaborating. How this however works with the outside world is difficult based on what we, because IBM needs to make money with their products, and if there are like algorithms that we are developing new, where now the focus is going to, rather than model developments, read the underlying to improve and come up with new underlying algorithms. Maybe have seen like the Alpha Evolve paper from Google, and so yeah, it's increasingly becoming a more difficult question, and this is something that, with my position within the company, I cannot really answer. Yeah, it's just because of my responsibilities are like not that high. On the other side is IBM, like through the AI Alliance, we really foster the international collaboration and also putting what we can open source into that and trying to bring the right partners and the right resources together. So this is what we definitely do in this space. But we are, of course, limited of what we can share as kind of models, but IBM is very big in releasing advances through IP or also through publications as well.
Santiago, any thoughts on the international landscape?
We'll keep watching it. That's all I got. Like these things tend to be more important once you have things that are already kind of like out and being heavily used. We hope to get there soon, but as of today, that is kind of like not the case, right? We're not attracting the attention of like all types of international regulators just yet.
So I have a different question that might benefit some of the younger members in the audience, which is what are you guys looking for when you're hiring right now? So how much AI skill does someone need to come in with to get a look at by your hiring team for typical jobs in your company? So if each of you could maybe address that. Abhijeet, you may not be hiring yet, but you've just been hired. Maybe they told you what you brought to the table and what they're looking for. So thoughts? Let's go with Santiago again. I picked you first. I'll be consistent. What are you guys looking for?
Sometimes it's easier to say what not to do than it is what to do.
Sure.
So let me just kind of try to give maybe one or two examples on what not to do. Don't regurgitate a superficial version of what it is that we already have, right? So essentially, if many papers have already been written on a particular way to run a workflow, it's probably not a good idea to try to make your pitch about replicating that, because chances are that we either already have some version of it if we believe it to be important, or we have decided against it. So then that means that, the classic advice is like be unique, and it's also kind of useless. But practically speaking, if you look at like an accepted framework, what are the areas of improvement that you can do in that accepted framework? And that can then lead you towards being a bit more unique, whether that is on the algorithmic side, and if it's on the algorithmic side, for what modality? Are we talking language modality? Are we talking simulation modality? Are we talking image modality? There's many different options there. Or is it a particular expertise in a particular field? Like, have you done something on a particular materials class that has unique considerations that because you did the work on there, you would know.
Yep, thanks. Tim, thoughts?
Yeah. In our group specifically, we are definitely looking for complementary skills. So when you have a research group that is like transition from material science into software engineering and AI, to somebody that comes with strong AI skills would for us very attractive because it could catalyze all the knowledge about materials already. So, and having a strong background in coding and good coding skills, good coding attitude and style is definitely, of course, helpful. There are a lot of tools out there that can be helpful to teach it, like courses or certain programs to check your code and code development and or review your code yourself with other kind of LLM products. That's definitely like having a very strong consistent workflow, how you approach things, and you can demonstrate that, how efficient that is, and how this can accelerate what the group brings itself. That is definitely something that's very convincing. And yeah, I cannot really say how much AI we would need to see for a candidate in our group, but you definitely have to have it.
Mm-hmm.
Yeah. Like working with different modalities is definitely beneficial, not only one modality.
Mm-hmm.
Yeah.
And do you still want that people to have core material science knowledge in addition to AI knowledge, or is it can you hire just a straight computer scientist and teach them something about materials on the fly?
That would work. It also depends on the type of project within our group, how much there's needed. We definitely have pure software engineers and AI scientists. For us, it's still valuable if there's like an overlap between coming with knowledge and material space and having a strong background or experience with AI. This is just based on our group. As a whole, when you look at IBM with the different research fields, it's becoming more and more important that you have very strong AI skills or even like a mathematic background, because IBM is going more into algorithm development also for quantum computing.
Right.
So using AI to come up with new algorithms. That is like one of the new focus areas for the company.
Right. Interesting. And Santiago, could you answer that last question as well about how do you want your new employees to know materials at some decent level, or is it fine to just come in with the AI expertise and learn
The less you
lab
have
part?
of one thing, the more you need to make it up with another.
Yep.
Is what I would say. Right.
Okay.
So, I mean, sure, what is Pareto optimal? Be a world experts in both, but that is kind of like that never happens. If you go the route of preferring one over the other, make sure that you know whichever one you pick really well.
Right, of course. Classic optimization. Yeah, Abhijeet, any comments from your more entry level perspective?
Yeah, so one thing obviously from like a startup perspective, it's important to like, fill in the skill gaps, kind of like a boring point here, but like, there is some skill missing. Get that person to, fill in that role and get the best person who can fill in that role, who's like more flexible or not. Sorry.
I think that was a stray comment. Just
Oh,
go.
okay. So yeah, so that's one of the thing. But a general comment I would say is like it's very hard to judge somebody based on like that there are so many factors, right? For example, somebody worked in like a really good academic group, big group, lot of funding, lot of resources, versus somebody from a small university did this thing. Both may perform more or less the same if you give them the opportunity to do that, right? So it becomes like a very hard thing to like judge somebody just based on like which university they graduate from, at least from like a early stage kind of like a thing, unless they have like a lot of experience in industry and other kind of things, then you can maybe like judge them along. For like a junior, it's kind of hard to like judge somebody because, as I said, like, different environments. And then the best way to like would be to like give them an internship or do like perform in that environment and see how they perform.
Thanks, Abhijeet. And I guess it's almost time to turn it over to David. I do think it was quite an interesting year, that 2025 was perhaps the first year with billions or many billions of dollars of VC capital injected into the system that we've all been a part of building, and it's really interesting to see it take off. I wonder if a parting comment from folks would be, what does the pathway to virtuous cycles and big positive feedback loops look like in your domain?
Not sure I understand what you're trying to.
Well, for VCs to get their money back, they're going to need, large returns. And the question is like, sort of, what aspects need to be built to enable those virtuous cycles in materials, which is not typically seen as a field that has that type of scaling?
Well, you just need to be able to show that whatever it is that you create can approximate those scaling behaviors more closely. So we talked before about the different handoffs in the material ecosystem. How much can you affect the scaling behavior by changing where those handoffs happen, right? So like if we can make a larger batch, does that change the economics? Is, for example, one question. If you can make a lot of smaller batches at high quality, does that change it? If you can, so those are the kind of questions that we'll have to answer. And there might be like different types of business model developments that stem out of that can then encourage more investment to like come through.
Very good. Yeah, it'll certainly be interesting to watch. I think, like you said, there's a lot of business model development to be done, lots to explore. It's a fairly greenfield area, so will be really interesting to watch. If anybody else has comments, otherwise I will turn it over to David. If not, I see he's waiting on the wings.
Thank you all again so much. This was a really scintillating discussion. We really appreciate the time that you put into it.
Yes, thank you.
Yeah, thanks everyone. Thanks to Jake, Cate, and Ben for jumping in and making that happen. And of course to Tim, Santiago, and Abhijeet. Really appreciate it. So that brings us to a brief summary of the day and really just pointing mostly towards tomorrow. I think it's been exciting already, the two panels that we've already had. I'm going to hope that I'm sharing slide here. It doesn't even have to be in presentation mode. The first panel, really, it was great to hear at the high level the types of things that are going on and the way the community is migrating from the interagency coordination that the MGI really was able to provide for us to ongoing coordination and integrating new ideas and new directions. And then this really exciting emergence of data-driven AI. So the panel we just heard, seeing how new some of it is and how it's being worked out as we go. Certainly, for those of us who are in academia, many of our students are really excited about this direction and are heading off towards internships for the summer or new jobs or other types of opportunities. So I think Cate's question there was really spot on. And this idea of figuring out how it really scales moving into the future is also really interesting. I want to point out that in MaRDA, we work by having working groups, and that we are launching 3 new working groups this spring to coordinate work between aspects of the community and different stakeholders. They're all really hot topics right now. One is about labs of the future writ large. Another is about AI-ready data, especially concepts, definitions, and what readiness really means. And the last is an extension of a group that we've had for a few years called Fair Train, which talks about workforce development and how this extends now with with not just working with fair data, but models and AI and the interaction between data and AI. So the purposes here are all in small letters, but we'll have more information out about those. And I want to point out that all MaRDA working groups are open to anyone who will follow the code of conduct and is interested in doing the work with us. And so you can, if you're interested in working groups, you can email info@marda-alliance.org, or tomorrow we'll have some links in the discussion that you can just put a check next to your name in those boxes that show that you're interested. And of course, working groups don't just come from the top down, but they also come from the bottom up. Really, MaRDA is a grassroots organization. And so we're really looking for anyone to start working groups on ideas that are important to them about metadata, or the infrastructure, or the way that we connect things together, ideas we've heard today. So without further ado, then, I really just want to point towards tomorrow, encourage everybody to come back. We've got great sessions tomorrow. This second sort of pushing on materials manufacturing panel, we've got industry goals and gaps for AI. And in that panel, that'll be moderated by Ale and Corinne Lipscomb from the council, is going to have 4 panelists from more traditional, perhaps, materials industry partners. Solventum, which spun out of 3M. We're going to have Jennifer Schumacher also from 3M, Alex Schmidt from Dow, and Joey Montoya will be here from the Toyota Research Institute. So these are really important large-scale industries that produce a lot of materials and do a lot of things with materials. And it's sort of a famous quote from Corinne from a few years ago, is that MaRDA is the only meeting where they hear about metadata. So it's a really important touchstone for us, and understanding of how fundamental research extends, as Jim Warren pointed out in his talk this morning, all the way across and translates out into real outcomes. And then the second panel tomorrow will be about academic perspectives on these labs of the future. And we've tried to make this particularly interesting. It's moderated by Caitlin Jones from NIST and Kyle Salibi from Georgia Tech. And we have 2 examples from academia. I'm going to sit in for Todd Huffnagel from Hopkins, who's on sabbatical. Taro Hidasugi is going to be here from the University of Tokyo to give us a very different international perspective. And then Peter Bocage from Lila Science will be here from one of these new companies. And Jiju will be here from Argonne National Lab. So we'll get really quite different perspectives on what these programmable cloud labs, self-driving labs, autonomous labs can really mean, and how they're being approached today, and where the gaps are. So I hope everyone will come back and join us again tomorrow for another great day. And thanks again, especially to the moderators and panelists and everyone who shared thoughts in the Google Docs. And with that, we're adjourned. Thank you, everyone.
Thank you.